So when we work with time series dataset, there is a concept of components related to time series analysis. So it is really important to learn about these components because it is widely used in working with time series dataset. So an observed time series actually can be decomposed into 4 components. So the first one is the trend line, and it shows the long-term direction of the time series dataset. And then the seasonal, which indicate the systematic or calendar related movement. So in this picture, you can see the seasonal movements in the brown color. And also there is a cyclic variations which appears annually. So in the brown color, you can see are also denoted. In addition to that, there are also random or irregular movements which are short-term fluctuations due to several unexpected phenomena. So if I explain more about these components, the trend shows the general tendency of the data to increase or decrease during a long period of time. So it is a smooth, general and long-term average tendency. However, it is not always necessary that the increase or decrease in the same direction throughout the period of time. So on the other hand, when considering seasonal variation, these are rhythmic forces which operate on a regular or periodic manner. They have the same or almost the same pattern during the period of 12 months. This variation can be present in a time series if the data recorded hourly, daily or monthly, less than an annual period of time. On the other hand, there is also cyclic variation component related to the time series data. So it shows the variation in a time series which operate themselves over a span more than 1 year. So finally, there is random or as irregular movements in the time series dataset. They are not regular variation and purely random or irregular. These fluctuations are not unforeseen and also unpredictable. This could be caused due to an earthquake, natural disaster, or a special phenomena that happen during a specific period of time. So in this video, I'll show you how we can utilize this trend and seasonality for a certain extent, and also I am going to use practical data sets related time series practical data sets for this next part of the lecture. So you can see for this example, I am going to use this particular data set. So it is rainfall and temperature data set which collected monthly from 2010 to 2019. So it is collected for a specific geographic location, and it has the month and also the year. So from 1 it represents the January and all the way to December for each year. So first of all, we have to import the dataset into the RStudio, and I have set the work directory. So first of all, let's see how our dataset is arranged. So from here you can see the starting the timeline is starting from 2010 January to ending with 2019 December. So for each of the month during that period, it has given the rainfall in millimeters and temperature as well. So first of all, what we have to do is we have to create a time series object from this data set. So we have to specify the starting date of the data set. And specify the frequency. So make sure to specify the frequency as 12, because in this particular data set we collect the data set monthly. So if it is an annual data set, you have to specify it as 1, or if it is a data set, a daily data set, it should be 365. So let's plot this data set and see how it shows. So here you can see how the dataset changes from 2010 to 2019. So for the first time when you look at this, you can't actually determine what kind of trend in here, or whether it is an increase or decrease. Likewise, however, if you decompose this into 4 components, you can get a clear picture whether there is seasonal changes, cyclic variations, likewise. So you can determine the trend line also. For that you have to import this candle library. So now let's see how the trend line goes. So the reason is I have forgot the rainfall argument here. So in here you can see how the trend line goes. So almost when you zoom in, you can see a very small variation. However, from in 2010 the rainfall is almost less than 60 millimeters. However, it has gradually increased over time. However, the increase is not significant. So likewise, you can get the trend line using the candle library. Now let's see how we can decompose this data set. For that you have to get the GG45 library. And use the autofloat function to decompose. So in the first graph, you can see our dataset, how it changes over the time. And in remainder, it mentions the noise of the dataset. However, in this video, I am not going to focus greatly on this particular graph. So in the seasonal graph, you can clearly see a particular pattern here, which indicate a seasonal pattern. So in here, you can see it starts from here, and it decrease and again increase. Likewise, you can see a seasonal pattern in the data set. So in here you can see a trend from 2010 to trend from 2010 to 2020. So next I am going to show you how we can use this process for annual data set. For that I am going to use the same data set. However, in this time I am going to aggregate the data set into annual mean values of the temperature, because we know the data set that we have using collected data monthly. So we can use the aggregate function. Since we are using the temp, we can specify the temp column. So we can get an idea about the data set. So now you can see it has calculated the mean value for the year. So we don't need the actually when you are creating the time series data set, we have to drop the time component. So like we did in the previous video, we have to filter only the temperature data. So we have to create the time series object. So as the input data set, we'll use the above variable and specify the start date. Specify the frequency as 1 since we are using annual data set. And finally we can plot and see how the data represents. So now you can see the mean temperature for the each year. So starting from 2000, you can observe a minimum temperature for that period, and by the time 2011 there is a sharp increase followed by a slight downward trend, and after 2015 you can observe a steady pattern. Let's plot the trend line. So here you can see the trend line, how it changes. Well, it indicates a slight increase over the period. However, the amount increase has been decreased from 2010 to 2019. And finally, before conclude this video, I want to show you another thing. So if we are going to decompose this data set, so you can see it gives an error message, time series has no or less than 2 periods. So as I mentioned previously, if you are going to calculate or decompose the entire data set, the data should be recorded at least monthly, or it can be hourly, daily or weekly. However, at least monthly data set should be available if you want to decompose. So since the relevant data set that we are considering here is an annual data set, we can't decompose it into the 4 components of the time series data.